Hello everyone again. We've got 6.4 and 6.5 now. We're going to prove triangles to be similar. And we start out looking at postulates here for proving triangles are similar. So we're going to think a little bit like we did when we were proving congruent triangles. But now we just need to prove whether they are similar to each other. Okay, whether they're similar or not. And so one of the things we know about similar triangles that I believe we talked about in an earlier video was that angles on similar will be congruent. Angles on your similar triangles will all be congruent. All three of the angles should be congruent to the three angles of the other triangle. Sides are going to be in proportion or in the same ratio. So let's look at the first one. Now remember, angle, angle, angle was not a proof for whether or not they were congruent, but we do have angle, angle similarity. Okay, and this is what you'll be using to show the AA similarity. Remember the little symbol, the little squiggle symbol means similar. So we have angle, angle similarity. That's one of the postulates we can use. So if we have two angles of two triangles, so angle K here and angle Y are congruent, and angle J and angle X are congruent. And so if two angles of one triangle are congruent to two angles of another triangle, then they must be similar to each other. Because really, doesn't the third angle have to be the same? I mean, if you think about that. But really, we only have to prove that two of them are the same. So determine if on this example, if the two triangles are similar. And if they are, we're going to write a similarity statement for the two triangles. So here's the picture of two right triangles, right? They both have a right angle. So we know that one angle in each triangle is congruent. The right angles are congruent. So angle D what did I do? Angle G are congruent. Okay, well, I already said that, didn't I? Angle G and angle, they're both right angles. Okay, now, if you get a picture like this, you had best figure out one of these other two angle measures. You can figure that out, can't we? Let's do, let's find K here. If I take 90, because don't the two angles H and K have to add up to 90? Since I already have a 90-degree angle down there in the corner, the other two must add up to 90. And so I can take 90 and subtract 64, and I'm going to get 26 degrees. And so now we know that angle C is congruent to angle K. Okay, so if you have triangles like this, you better find out what that third angle in one of those triangles measures. Don't just guess. Make sure you find out what that third angle in one of them measures so that you can make sure that they are congruent. Now I have two congruent angles, and so I can say these are similar by angle, angle similarity. And let's write the congruency, or the similarity, not congruency, sorry, I hope I don't do that, but similarity statement. And here's how the similarity statement looks. I'm going to say that triangle CDE is similar to the squiggle. Triangle, now, since I started with C, and that's my 26-degree angle, I have to start with K on the second one. And then I go to CD, I went to D, and that's the 90 degree. So I have to use G here. Second letter should be the 90-degree angle. And then the last one, we went KGH. And there is your similarity statement between the two triangles. Okay, let's also look at the next one we have, which is side, side, side similarity. And if all three sides can be shown, I stress that, you must show me that they are all in the same ratio. We want corresponding sides to be proportional. And if corresponding side lengths are in the same ratio, then the triangles would be similar. And so we want to know if either DEF, this one, or GEH, I'm sorry, GH, oh, this should be a J. That should be a J. GHJ, that one, Are they similar to this first one, ABC? Okay, so we have to set up some ratios, and they have to be of corresponding sides. So if you have a similarity statement, so if we look at if they're similar, we want A, B, letters 1 and 2, A, B, to be similar to DE. Now, if you're not given the letters in the order, if you're not given the letters at all, then what you want to look for is on ABC, I want the smallest side, which is 8, right there. I'm going to draw over the number, 8. And it's going to be in the same ratio, hopefully, to the smallest side of the other triangle. So we would want AB, that ratio of the corresponding sides, AB over DE, and see what that ratio is. So we've got 8 over 6. Divide both by 2, and we got 4/3. So that's the ratio of AB over DE. Now let's go to the middle number, 12. BC over, and the middle number here is EF. BC is 12, and EF is 9. Divide both by 3, and we've got 4/3 again. So now we've just got to check the last side. AC is the longest side, AC, and it should correspond to the longest side of the other triangle. So DF. AC is 16, and DF is 12, and divide both of these by 4, and I get 4/3. So, since ABC and DEF have the same ratio, these are similar. So let's write a similarity statement for that. Triangle ABC is similar to triangle DEF. So that would be your similarity statement for those two. ABC is similar to DEF. All right, let's check the other triangle. Let's use a different color. We'll do blue. And so AB, again, smallest number to smallest number. So we can look at AB, and that ratio of GH is 8 over 8, which is 1. Now, I'm sure you already can tell. Well, let's go ahead and look at it. Let's do BC. BC over, what would that be? HJ, middle number to middle number, HJ. So 8, I'm sorry, let me go back. BC is 12, and HJ is 10. And 12 over 10 does not reduce to 1. If I divide both by 2, I get 6 over 5. So these are not equal. The ratios are not equal, so they are not going to be similar. Okay, so that's your side, side, side similarity. You have to be able to prove the ratios of all corresponding side lengths. Okay, you have to prove that all three over here. Look at the first one. We did all three ratios. So if you're going to prove to me that two triangles are similar by side, 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 I want to see 3 ratios, and they better all be the same. Okay, last one to prove similarity is side angle side similarity. Right here, side angle side. If an angle of one triangle is congruent to an angle of a second triangle, and then the lengths of the sides that form, and they have to form that angle, are proportional. The two sides that form those triangles, or those angles, are proportional, then the two triangles would be similar. So let's look at these two triangles right here. Now, I'm not given parallel lines. I don't know anything about that. So I have to look at the two triangles and see, well, what angles can I prove to be congruent? And the only ones I can prove to be congruent are these right here. And I hope all of you were looking at it and saying vertical angles. I hope. So A, we're going to look at what method we'd use, and that's going to be, hopefully, if my sides are in the same ratio that form these angles, and I've got two congruent angles, then I'm going to use side, angle, side. Side, angle, side. That's what we're hoping for. Okay, so I'm just on part A still here. I'm going to say that angle ACB we know is congruent to angle. Now, we do have to go with ACB. So we started with the side that has the larger number on it. And so down here, this larger number side is going to be the corresponding side. So we have to start out here at D and say angle DCE. We know those are congruent. So there's my first part of explaining how I know these two are going to be similar. Next thing we have to go is the ratio of sides. And so the ratio of sides, AC, and it's going to be corresponding to DC. So the ratio of AC over DC is 18 over 30. And 18 over 30 reduces to 3 over 5. Now let's check the other ratio. We've got to check the ratio of the other side. BC over EC, and BC is 9, and EC is 15. Divide both by 3, and we get 3 over 5. Same ratio between the two sides, the two corresponding sides, and again, it has to be the sides that form the angle right here that we're looking at. Okay, the angles that are congruent has to be the sides that form that. And so since they are congruent, now we can write a similarity statement. Triangle ACB is similar to triangle DCE by side, angle, side, similarity. Okay, those are the three types that we have, and that's it really for 6.4 and 6.5. Just time for you to practice.